Stanford University.
I was going to do it, but you know, they got totally screwed up.
Yes,
Welcome. Second week of EE 380 2008-2009 spring. Those of you who are taking this for credit, please remember to do the comments for each talk. And we've found in the past that people who do it every week tend to finish. People who don't do it every week tend to not finish. Earlier in the week, these slides were not up. I believe they are up now. However, you might find them better for review than going ahead, but you know, we can't stop you if they're up. As most of you know, engineering is about creating solutions within constraints. It's not about, as a friend of mine put it, transforming beer into circuits. And many of those, although not to say anything against beer, I didn't mean, but the circuits have to satisfy constraints. And often, or almost always, some of these constraints involve money in some form. And just sort of to tie this back to a bigger thing, as I understand it, biz schools were actually invented to teach engineers how to run businesses, and before they sort of wandered off into what they're doing now. And you often hear engineers who have successfully started businesses saying that, hey, the business stuff was the easy, it was the technology. So, you know, we're an engineering school, why don't we do a better job with this stuff? So, along that line, this quarter we're going to have a couple of talks about money, economics, and how to make things work out a little better. Today's talk is about platforms, which are an economic structure that involves shared technology in a community of reuse. And I was trying to think through platforms and come up with why platforms are bad, and I really didn't come up with a stakeholder for which platforms don't work out pretty well. But yet platforms are rare. And why is that? If they're a win for almost everybody, why are those so hard to create? Today's talk is about why that is and how we can help our odds. Michael Mace has been helping people make platforms and helping engineers figure out this money stuff and make organizations work. Thank you.
Thanks. And man, this is going to be fun. Chances are that a number of people in the room will know more about some of the history I'm going to talk about than I do. So it'll be a shared voyage of discovery. I'll invite you to jump in to correct me kindly and gently if I get anything wrong. I am going to reserve the right, if folks start going off on a big tangent, to kind of cut you off and say, let's save that for the end, just because some of these things are holes that we can go meander down and talk about for a whole hour. But basically I want to share some stuff that I think about the industry that I've seen over the years and that we've learned from working with various clients. So let me ground this really briefly. So here's the obligatory slide about the place where I work. The quick thing to understand about this is we're a small, deliberately small consultancy in Los Gatos. We work just with the tech industry. We do business strategy for tech companies. So if you're ever in a situation where you have a business or product strategy problem, the harder the problem is, the more I want you to call me. Fair enough. So about me, my background. I started off way back when, in the early days of the Macintosh, as a software developer for the Mac. And that was my beginning. And ever since then, I've had a really strong love and affinity for little tiny software developers and all of the things that they go through trying to deal with the marketplace. Out of that, I got a job at Apple. I was there for about 10 years in a variety of different marketing and strategy roles. And after that, I did a few other things and eventually ended up at Palm and PalmSource, where again, I was doing a mix of marketing and strategy things. And one of the common threads throughout all of this stuff was I was always dealing with the platform side of the company, the operating system and the developers, and working on all of those things. And I watched a lot of that over the years. I saw how things developed and had a lot of thoughts about it. What happened was we got called to do a talk at Intuit about 3 or 4 months ago. They'd seen something I'd written on my weblog about platforms, and they called us up and said, you know, we're working on platformizing our software. We want to take our really successful applications and turn them into a platform, and we'd like some feedback. We're doing an all-day seminar on how platforms work and how they succeed. Come in and give us your perspective. So the nucleus of this talk, when we started it, was that discussion with the guys at Intuit. And we've kind of fleshed it out and added some more to it. So first observation I want to make as somebody who does consulting across the industry is right now everybody wants a platform. You know, the tech industry is subject to fads, just like society as a whole. And you'll get times when, you know, everybody decides that they have to have something. Like back around 2000 or 2001, everybody had to have a web portal because that was going to be the thing that was going to be wildly successful. And in fact, very major companies were completely redirected in order to turn themselves into web portals until, of course, we found out that wasn't actually a way to make a lot of money. Platforms, there actually are ways to make a lot of money. However, a lot more people are working on them today than necessarily really understand how they work. And this trend toward wanting to do a platform, I think, has been driven by the business success or the perceived business success of several key products recently. And it comes down to Google Maps, Facebook, and the iPhone App Store. Google Maps being by no means the only, but one of the canonical mashup products. You know, Google puts something out there, they expose APIs to it, and all of a sudden a whole bunch of other people are building things on top of it. And folks said, wow, that's a really neat model. That's a great way to drive innovation. You know, we won't just try to do something ourselves, but we'll do the nucleus of it and other people add on top of it. Facebook, you know, for a long time was down below MySpace in terms of perceptions and usage and way down below them. And one of the things that enabled them to reach the prominence that they've gotten to today, and you know, I'm not going to say which one's number one because you can get different numbers on those, but definitely they've gotten a lot closer, was they opened it up and they enabled developers to do extensions to what you could do with your pages on Facebook. So they made themselves a platform. And again, a lot of people noticed and said, wow, that's really cool. We should be doing that as well. And then finally, there was the App Store from Apple. Applications for phones were, for a long time, viewed as a backwater, a dead end, something that's not going to yield a lot of revenue. You know, sounds nice, but it just doesn't work. Until Apple put together this whole proposition that made it easy to discover and install those applications. And all of a sudden, you have this big explosion of activity. And all of a sudden, I can tell you, every handset company wants to have its own platform. Every carrier wants to have its own platform. They're all after this whole thing. So it's a very hot topic that we get tons of questions about all the time. So in order to talk to the Intuit guys about it, what I wanted to do was not just give them current thinking about the platform stuff, but try to put it in a little bit of historical context. So where did this idea of a platform come from? You know, what's it all about? How did we get to this point? And it turned out to be really difficult to find the information. Now again, my guess is there's some folks in this room who grew up with this stuff, who know it for themselves, and it's not going to be news to them. It was news to me. It was surprising how difficult it was to find a bunch of this stuff, even using Wikipedia and stuff like that. So I want to share with you what I found when I went digging around. So here's my agenda for the rest of this talk. I'm going to give you a little bit of a history of software platforms. I'm going to then turn it to the practical information about, okay, based on these observations, what makes a platform win? And then a little bit of speculation about where will the industry go next. So the sequence here is history, practical tactics, and then head in the clouds theory. And then we'll have discussion afterwards. So first of all, my first observation, I think we as an industry as a whole remember hardware a lot better than we do with software. First of all, it's physical. You can see it. People tend to get more emotionally attached to it. You know, I love my Macintosh. People will tell you. They don't really very often say, I love Microsoft Word, you know, or PageMaker or something like that. It's usually the device that they get attached to. The software is an intellectual tool. The device tends to be emotional attachment. And, okay, there are other issues around Word. I can see you talking to each other already. Yes, you're right. But even if you picked a good, you know, piece of software that's not overwritten, you still get those issues. So an example is a lot of people in the Valley, you know, if you say, hey, what was the first computer? They can tell you, oh, yeah, you know, it was ENIAC. And sometimes there's some argument because there were other things that were kind of right in that same time frame. So I don't want to, you know, go on to a 20-minute sideline about that. We can do that later. But the general consensus that it was ENIAC, and that was back in Pennsylvania right after World War II. And these nice ladies here, by the way, are programming ENIAC. And the way you did it was with patch cables. Okay, so you would physically move the cables to change the programming on the device. So this is pretty well remembered. You know, if you look up first computer, you get all this stuff from Google, and there are IIAC simulators online, so you can find out, you know, what it was like to program IIAC. And there's a big industry history of IIAC that you can get information from. That's where these photos come from. There's all sorts of information on that. The next question, though, was quite a bit tougher, which is that computer, IIAC, was designed by the government for solving government problems. So they used it for some scientific stuff, and they also used it for, frankly, military things. You know, it was supposed to calculate artillery tables and things like that. Given this wind and these conditions, you know, what angle do you set the artillery at to make sure you're going to hit the thing you're shooting at? Very calculation intensive, very practical. But at some point in time, we ended up using these things for business, and that wasn't where they started. And finding out the first business computer turned out to be quite a bit harder to do. And it turns out that the answer involves Jelly Roll. So there was this company in England at the end of World War II, which was called J. Lyons and Company. And they ran the largest chain of tea shops in Britain. Now, tea shop, to me, an American, tea shop means like a place where you go to buy bags of tea. That doesn't sound very interesting. But if I say coffee shop, you then get a much better idea, because that's what J. Lyons was running. They were running this enormous chain of what we would call coffee shops. It's like Denny's, okay? Fixed menu, same menu at every place. It's cheap food, you go there. And this is where, during the war, before the war, after the war, kind of the middle class people and working class people in England would go to get a quick bite or get a little snack like some Jelly Roll or something like that, and meet with their friends and talk. And it was the place to go to. So it was an enormous organization. It had, it's just in England, right? 30,000 employees. They served 150 million meals a year, and they served 36 miles of Swiss roll. There it's called Swiss roll, here it's called Jelly Roll. I don't understand why. That's another one we could spend half an hour on. But just take my word for it, they called it Swiss roll. And they served 36 miles of this stuff every single day, cut into little slices, and they managed that entire business on paper with little tabulation machines. You know, so payroll, taxes, revenue, all of the materials they had to do, running all of the different stores that they had to run, calculating how much Swiss roll they had to do the next day. That was all being done by hand, and it was unbelievably inefficient. So J. Lyons was a very progressive, very aggressive company back then, and they heard about these computer things that had been worked on, and they said, you know, it's just what we need to calculate the Swiss roll. And so they went to Cambridge, because you couldn't buy a computer. There were no computer companies. The industry hadn't started yet. They were just being put together by hand at various universities. And Cambridge was working on a computer. And they went to Cambridge and they said, we want you to build one of these things. And they paid them $5,000, which is like about $50K in today's money. So yeah, pretty good money. And Cambridge built them a computer, which was called the Lyons Leo. So this was 1951. So already we're several years after the invention of the computers, about half a decade after computers were invented. This thing occupied 5,000 square feet, so that's like, you know, bigger than a house. And it had 4K of memory, and the memory units weighed half a ton because they were all full of mercury. So we won't even get into the health stuff associated with that. I have no idea. But anyway, the thing got built out for them. They started using it in 1951, and they could all of a sudden process somebody's wages in 1.5 seconds instead of it taking 8 minutes. So an enormous increase in productivity. And in fact, sometimes you'll hear economists talk about, you know, how for the first 30 years of computers, they couldn't figure out if computers were actually increasing our productivity. And as far as I'm concerned, we just weren't counting it right, because there must have been an increase given these differences. And they did with it eventually all of the sorts of things that you would expect to do with a business computer today. They did payroll and inventory, order management, and all that sort of stuff. It was so successful that eventually the Lyons Computer Company was spun out as a separate company. And they were quite successful for a long time. You know, there are structural reasons why the UK wasn't able to become the most dominant area in computers, but they pushed it as far as they possibly could. And this guy, the person in the photo up here, deserves special credit. His name is David Kaminer, and he was the guy who kind of did the first business apps on computers. You know, whether you call him an analyst or a system programmer, system analyst, it's not clear what the exact appropriate title is, but everybody agrees he was the one who drove the apps for this. And so he really is the first business apps programmer, probably. That's the right way to describe it. So that's pretty cool. You don't hear much about him. You can find information if you look up his name, but certainly it's not as easy to find as some of the other luminaries in the industry. He just died about a year ago, unfortunately, but he went on to have a very distinguished career. He did a bunch of computing stuff for the EU, so really quite an influential guy. So that's how computers got started, business computers got started. Now, it's interesting. Yeah.
Back in the United States, in the meantime, IBM with its tabulating equipment was doing payroll and inventory and all those things right then. And you also had a program using a plug board.
Yep. So here we are. This is exactly. You guys know some of the history better than I do, and so one of the things I want to do afterwards is make sure we flesh out the story and kind of get it all straight. But you're exactly right. There's this long history of what they did with tabulating machines and punch cards and other things like that. The distinction here is electronic, I think. You know, electronic computer as opposed to doing some of these things with some mechanical elements to it. But let's talk about it afterwards. I'd love to get more detail on it. But anyway, so you've got these electronic computers now being sold. At the time, the whole idea of software was apparently pretty synonymous with hardware. I mean, the apps were sold along with the computer. Even the notion of trying to separate those things was kind of this weird esoteric idea. And in fact, the term software did not appear at that time. There's controversy as to who made up the term software. There are different people who claim to do it. The best verified claim that I can find is from this guy. His name was John Tukey, statistician. He worked at Bell Labs and also at Princeton. Among his other credits, he helped to design the U2 and he popularized the term bit. One of the things I love about this history is there are all sorts of weird little stories about interesting people in there. Anyway, he is the person who first made the first verified use of the term software. And that was in 1958. There are other people who claimed that they said it before, but it wasn't in print. He was the first guy who published. So he gets the credit for it. And I'm still trying to figure out what exactly was software called before we called it software. And it looks like maybe it was like programming or program or something like that. Code, yeah, fair enough. So, but the idea of software as this separate thing was an idea that gradually evolved as opposed to something that just sprang up at the moment when computers were first being brought along. So you get to this situation. This is now 1958. So you're looking 10 years, more than 10 years after the first computers had been made. So really, this evolution kind of moved gradually over time, like peeling an onion. So the next question is, what was the first third-party application? Since apps were bundled, somebody knows that, okay. So since apps were at first bundled and they were just part of the computers, who was the first person who actually went and said, you know, I'm going to write this thing separately and then sell it as a separate commercial product as opposed to just libraries of software that came along with the hardware. And this one turns out to be controversial. There are different claimants at it. It was very difficult to figure out exactly, well, first of all, to find the information, then figure out who exactly did it. But it looks like the most coherent story I could find came around flowcharting. And it worked like this. So there was this company called Applied Data Research in the mid-1960s. So we've now gone forward again several years to the mid-60s. And at the time, software companies existed, but they were all custom programming houses who worked with the mainframe companies, and they would develop things that would then get bundled with the mainframes. So not a really exciting business, not a lot of money in it, but you know, kind of custom business programming, the way we'd think of it today. And they wanted to work with RCA. RCA at the time was an up-and-coming mainframe computer company just starting to sell mainframes. And they proposed to them to do a flowcharting program. So this is flowcharting to take your code for your program and produce a flowchart from it, which sounds fairly elementary to us, but you know, think way back when and what the tools were like then. And being able to get a good flowchart of your program was very useful for documentation, for debugging, and all sorts of other things like that, finding sections of dead code, other stuff like that. It didn't have the sort of automated tools that we have today. So they went to RCA and they said, hey, we would like to do this, this flowcharting program for your computers. And RCA said, no, we're not interested. And Applied Data Research said, well, you know, actually we think this is such a great idea. We're going to go and we're going to develop the prototype anyway because we think we can do a really good job on this. So they spent about 6 months and you know, thousands of dollars, which at that time was tens of thousands of dollars, developing a prototype of the software. And then they went to show it to RCA again, and RCA said, no, we're not interested. And they showed it around to the other companies in the industry, the other mainframe companies. They all said, yeah, we don't want it. And so now Applied Data Research had something called sunk cost. And we were talking about business feedback for engineers. And what they teach you in business school is when you got a sunk cost, you ignore it because it doesn't matter how much you spend on it. You should give up and you should move on to something else if people don't want it. But that's not how any computer companies ever behave. What they always do is because they've spent a lot of time on it, they're really devoted to it, and so they keep trying. And so somebody decided at Applied Data Research, they said, well, why don't we just send letters to all the RCA customers, and there are only about 100 of them, so the postage is not going to be that bad, and we'll just offer them the software that they can buy it themselves. They said, well, that's a crazy idea, but why don't we just try it? So they sent out 100 letters, and 2 RCA customers got back to them and said, yeah, we'll take it. And that was, as far as I can tell, the birth of the independent commercial software industry. Because off those 2 products that they sold to RCA, they then said, well, RCA's got 100 computers, IBM sold thousands. So if we sent letters to all the IBM customers, if we port it to IBM and then we offer it to them, we'll probably make a bunch of money. And so they did contact all the IBM customers. The product sold well. They started doing a whole number of other additional products, and it started going along very, very nicely. IBM hated the idea because IBM was doing free software for all of its computers, and IBM, as we all know, was all about account control and customer control, and they didn't want anybody else messing with their customers. And so what IBM did is they started saying, well, you know what? We're going to do our own version of that flowchart program. We're going to give it away to you for free, so you can just have it. And in fact, what ADR says is, as they started to announce additional products that they were going to bring to market, IBM then immediately said, oh, we're going to do that for free. And what it did was it froze the market. Because the customer said, okay, well, since IBM's going to do it for free, maybe I'll buy yours, but I want to wait and see IBM's. Since it's free, I'll just wait. And so what happened was they couldn't sell any products, and then of course IBM took its time about shipping the free version. And if you're a little software company, that can just bleed you to death financially. So Applied Data Research didn't like this. And there were other companies by this time trying to do software. They didn't like it either. So they complained to the government, and they said, gee, we think this is really unfair. The government filed an antitrust suit against IBM in '69. ADR filed suit as well. IBM settled in 1970, 69 to 70, and they agreed that they would unbundle software from hardware. And it was from that the foundation of the software industry was built. Now, there were all sorts of continuing shenanigans that went on with IBM, which things did they continue to bundle versus not? Could the OS be free versus was the OS paid for? All of that sort of stuff. But this was really the foundation on which the software industry was eventually built. So, want to give credit to some folks. Martin Getz was the project manager on this AutoFlow product. He is also the holder of the first software patent, which may make him a hero to some people and may make him a completely evil person from the perspective of other people. I'll leave religion out of this. You can make your own judgments on it. Mike Guzik was the lead programmer on it. So I think these guys deserve to be credited as real pioneers in getting the software industry going. Interestingly enough, neither of them even appears in Wikipedia, which is one of the reasons why this was so hard to find. So a little sidelight here. So there's the headline from Computer World when the first patent was issued. And if you can't read the headline, it says, front page of Computer World from '68. First patent is issued for software. Full implications are not yet known. And I'd argue that headline is still correct today. I mean, that's one of the best tech headlines of all time. So, okay, so the next step was, so we've got people now developing separate applications and working with them. But when did the platform vendors flip and start saying, gee, that's nice to have applications as opposed to, oh, those guys are really annoying, they're getting in the way. And it's been really hard to find that. That's when I'd love to talk with you guys, if you know some of the details around it. Who did the first separate SDK where they were specifically encouraging independent development as opposed to just in-house development or something like that. I'd love to get some discussion of that because I haven't been able to find it. But clearly one of the key milestones in this was the evolution of the concept of the killer app. An application that would drive demand for hardware, because that was the psychological change that had to happen in the industry. And that happened sometime in the 1970s. It's not clear exactly when. Maybe it was a gradual thing that happened. But one of the big milestones was from this guy and this product here, which I presume some of you will remember quite well. So that's visicalc. In 1979, and the gentleman there is Dan Bricklin. He's posted this whole story online, so you can get lots of documentation about the way that came about. It was for the Apple II, and it became one of the key drivers of Apple's success. I mean, without visicalc, it's hard to see Apple II going as far as it did in the marketplace. So this was really the realization that software could be a driver of hardware demand, and that therefore that companies needed to go encourage software developers to come along. One of the little artifacts that's posted online is this analysis written by a guy named Ben Rosen. So if you know industry history, Ben Rosen eventually became the founder of Compaq. So very, very big guy in the industry. But at the time, he was just an analyst working for Morgan Stanley. And he saw visicalc, and he had a lot of trouble writing about it, because we didn't even have the term software at the time. So he actually described it as a tool that lets me make the computer do things that I want it to do. And at the end of it, he wrote, visicalc could someday become the software tail that wags and sells the personal computer dog. So he saw it, right then. He had the whole picture on it. I wanted to credit him for that. Yep. So that by '79, by '79 they were using it. Yeah. So okay. So then what was the next step in all this stuff? So now applications were really seen as being separate from the hardware. The next step, I think, in evolution was the separation of the operating system from the hardware. We all know how this one happened, so I'm not going to belabor it too much. IBM came out with its computers. It signed up Microsoft in 1980 to supply the operating system. It shipped the computers in 1981, which validated the whole design and the architecture, made everybody feel safe buying it. By 1982, Microsoft had licensed the operating system to 50 other manufacturers. So that led directly to what I think personally is one of the creepiest pictures in the history of the computer industry, which is right there. So I'm not sure. I mean, we're in the Gates building. Am I allowed to say it's a creepy picture? I'm not trying to make fun of the man himself. Here's the issue. If you become a multi-billionaire and you're running your own really big computer company, for God's sake, the pose, okay, is like this. Think Larry Ellison. Do not lie on the desk. All right, that's not the pose you want to do, because it'll come back 20 years later. Okay, so that's my quick history of how we got to this point in software platforms. And the big thing I want you to take away from that is this gradual peeling of the onion. That it wasn't like I think a lot of us would just assume today, it was intuitively obvious that software is really important and you want to do a platform and all this other stuff. No, those ideas evolved over a period of several decades, and it was gradual realization of all this stuff that had to happen in the industry. So the second question is, now that we know that platforms are important and useful, what makes them win? What do you want to work on to make them successful? So a couple things have happened lately with platforms to make that even more important. First of all is the whole mashup thing that I already talked about on the web, with people adding APIs to their web services in order to let them cooperate with each other. This is Google Maps transformed into the game of Risk, by the way, in case you're wondering. That was one of the first prominent mashups for Google Maps. Very quickly thereafter, killed and removed from the web by the people who actually manufacture the board game Risk, but that's a different story. The other thing was mobile and what went on with mobile APIs. So I've got a chart showing how that worked. So this is for a particular mobile platform. This was their 1 year. In just 1 year, their growth in number of registered developers. They went from 3,000 to about 23,000. So really intense growth. Anybody want to guess? I'm sure some of you know which piece of hardware it was that drove this. Yeah? Nobody's BlackBerry? BlackBerry? Well, that's a pretty good one. It was actually Palm. From 98 to 99. I remember this one because I was there and we made this stuff happen. So sometimes, and by the way, the one you're supposed to be assuming, which most of you are probably assuming, was iPhone. But whether you're thinking BlackBerry or iPhone, this is a reasonable guess. With the usual reaction that I get when I talk to this one is, well, wait a minute, Palm isn't successful, so that's really, that's not fair. Really, Apple's very different because Steve is a lot smarter than the Palm guys were, and Apple's doing these things a lot better. So there's no way they're going to have that kind of drop-off. There's no way that could possibly happen. This is an entirely different situation. And if you want to convince yourself that therefore we can ignore the lessons of the history of the industry, that's totally fine, and you can just kind of tune out the rest of the presentation at this point. But my observation would be that, in fact, there are lots of computer platforms. There are very few successful computer platforms. Most of the people who try to do platforms eventually fail. So for instance, there was this thing called the Commodore Amiga, right, which had its own applications. Very beautiful stuff was done there for a long time. Don't see that still being in business today. There was DR-DOS, a competitor to Microsoft DOS. Some say a better product, but did not succeed in the marketplace long term. There was, of course, the whole Commodore thing, everything that went on with them. Next, yeah, we remember that one. And again, if you want to be in denial about Steve's constant, always getting everything right, we don't have to talk about that one, but it was a platform.
Where did the next platform go after Next?
Well, the next platform went back into Apple, but it.
Successful.
Yep. So I would argue, and we can get into the discussion on it. I would argue that Next as itself was a failure, but Next brought into Apple was a success, and that tells you something about the business factors that cause success as opposed to technology factors. B. Yeah, there's another one of the Apple ones. Know those guys really well. Taligent, anybody remember that? I was at Apple at the time of Taligent, and I had an old Taligent T-shirt, and I was going to get printed on it. Apple and IBM spent $100 million on Taligent, and all I got was this stupid T-shirt. OS2. Ooh, no, it burns. Stop. Okay, so Newton. Yeah, there was that one. We're getting closer to the mobile space now. There's Microsoft Windows Mobile. Really, okay, it's still on life support, still around, but in terms of becoming a self-generating, self-perpetuating success, not really. There's the whole thing, Java. Java, very successful on the server side. Client-side Java, if you talk to people doing Java apps in the mobile space, they're not happy campers because of problems with the platform. UIQ was something on Symbian in Europe. You probably never heard of it, but certainly Sony Ericsson did because they standardized a bunch of their smartphones on it. Not successful, now being killed. There's the Palm thing, which I bear some of the responsibility for. And Facebook, which some people view as a success and some as a failure, and I'm going to talk about that in a minute. But the big thing I want you to get is there are a lot more platforms that get tossed out there than actually end up being long-term successes. And the people who get burned the most are not just the platform vendors, it's the developers who invest in working on top of those platforms. So it's really important if you're looking at being a developer to understand why is a platform successful and what should you look for.
Well, by that measure, is Viziana a success?
I'd want to think about that one some more. Let's talk about it offline afterwards.
But why don't you mention Bob as an example?
Well, I couldn't list everybody. I mean, let's yeah.
I think that's one of the things that actually makes our industry a little different is the fact that we have, in many cases, pairs or teams of people as opposed to single individuals.
Yeah. I wasn't trying to leave anybody out. It's just a matter of.
Because Bob is, in many ways, far more fanatic about things than Dan is.
Cool. Fair enough.
Is this good or bad?
Well, you know what? Actually, you know what, guys? Because I do want to be sure we get through all the material. I'm gonna put this one aside for the moment. Let's come back to it because I do want to make sure we get through all the stuff.
Number on the ratio, successes to failure.
Ooh, I haven't tried to calculate the ratio, but
like startup companies 1 to 100 or whatever.
yeah, it's the ratio is, well, you know what? If you look at all the people who are trying to platformize their stuff on the web versus how many are actually getting traction with it. Yeah, 1,000 to 1 may be a very good estimate. So the web has made the ratio much worse, but that's because there's a lower barrier to entry. People doing serious platforms in the past, it was probably like 20 to 1 attempts versus success, something like that. And a lot of it depends on how you define success, because you might have different motivations. Sometimes success can mean, I just want to get a marketing boost by having a bunch of developers. I don't care if the developers ever make any money. I just want to get a bunch of people talking about me. Some would argue that that's what Facebook was after with what they were doing. And so in that case, you don't care if the developers get rich. On the other hand, you might want the developers to add some additional features that you don't have time to develop. A lot of companies that do platforms have this fantasy. Oh, I'll platformize it, and then people will do the boring part of the code that my engineers don't want to do. Like they'll develop all the drivers for me on their own. Doesn't usually work, by the way, because the people doing stuff for free want to do the fun part, not the boring part. But nevertheless, it's a thought that a lot of people have sometimes. And then you care somewhat about the developers being commercial successes. On the other hand, your motivation might be, I really need people to help me reach markets that I couldn't reach alone. You know, we're going to get this thing specialized for different verticals. We're going to go after different targets. I need the software developers to help me do that. In that case, you care passionately about their success as businesses because you want them to be motivated to continue doing that stuff. And so it really depends. Whether it's a failure or success depends on what you're trying to accomplish. Yeah.
How would you rate Microsoft Windows against these criteria?
Excellent. How would I rate Microsoft? We're going to come back to that one in a couple of slides. So thanks. So the question is, if it's really about motivating developers, because you had to jump back for a second, what I want to talk about is, let's see if I can use the laser, this stuff down here, where you do care about the success of developers, because that's what's really, really challenging. So if you care about making developers successful, you got to ask what motivates them. And I think it comes down to two things. The first is the ability to do something really spectacular that will get you status with your peers. You know, It's an easy program it's an easy environment to develop on. I can do a really cool app. I can show it off to other people. I love the empowerment. It's not just showing it off to friends. It's the feeling of empowerment that a good engineer gets when they get a really good tool that lets them do new things really easily. That rush, that feeling of power and I can do great things is a huge motivator, especially for a lot of developers who are just starting out, college age or just out of college, stuff like that. They get really, really excited when you let them do something neat, and that is an important motivator. It's part of the success of a platform. The second piece is this stuff. And what usually happens is those young developers who get really excited and come in there, eventually, they graduate, they have to have housing, they maybe get married, and they've got a spouse, they've got to pay for them, and all of a sudden it eventually becomes really important to actually be able to make some money off of this stuff, or they will be forced to go work on something else. So you'll see a lot of platforms where they let people do something cool, and a lot of developers come in like a big tidal wave coming in, and then they can't make any money, and the water rushes right back out, and it goes right back out of the platform because you haven't made it sustainable. That is probably one of the biggest problems that happened at Palm, by the way, and again, that'd be a whole separate half-hour conversation. But if you don't attend to both of these things, you don't get a viable platform long-term. So how do platforms fail? A few examples of what's gone on with them. Java on mobile. Again, I'm not trying to beat up on Java on servers. That's an entirely different thing. But on mobile, what happened was Java got splintered into all these different versions on different phones. And so rather than write once, run everywhere, you got write once, run in one place, and then rewrite to run in the next one, and rewrite to run in the next one. Well, when you can't charge a lot of money for the apps in the first place, if you have to rewrite them all the time, it is just not economically feasible to do a lot of development. And it just killed a lot of the developers who were trying to do this stuff. It was also very, very hard to get on device because you didn't have the app stores. So you had to work through the operators to convince them to carry your application, which meant you had to have this big sales staff for an application that you were going to get maybe 10 cents a copy for. I mean, just the economics just do not work well at all. There are a few companies that are successful, but what they're really successful at is they're really good at kissing up to the operators and getting them to bundle their apps, and they're more about sales than they are about development. So Palm and Windows Mobile, what happened to us? Very, very hard to find the apps. There was no software store built into those things, so it was very difficult to get to them. The financials for the stores that did exist were outrageous. So if you look at the stores that have been available traditionally for Windows Mobile and for Palm, they typically take 50 to 60% of the developer's revenue just to be your channel. So consider, typical retail store would maybe be marking stuff up by 10 or 20%. These guys were taking 50 to 60%. It broke the economics of the mobile developers. Simply didn't work for them. Facebook. Facebook is that tidal wave going in and out. And I know there's still a lot of Facebook apps. There are a lot of people who are very enthusiastic about it. But there are tons of Facebook developers out there who are not doing their stuff anymore and who are really, really pissed. Because they got in there and they found it was almost impossible for them to monetize. And then no matter how much fun they were having, no matter how many users they were getting, they had to do something to get food on the table, and they had to move on to something else. So the Facebook folks, either because they were treating it as a marketing tool or because they just didn't understand how the dynamics work, they didn't take care of the economic sustainability of the platform, and so they've lost and they've now pissed off a lot of the developers who are most excited about them. Not saying they're dead, but it definitely, there was a time when they could have taken over a big chunk of the industry. They could have been a big focus of web app development, and I think that time has kind of slipped past them now. Yeah?
Doesn't that get to a fourth motivation for a platform owner? Namely to have everybody go out, find the gold mines, and then go in and take them over. That's been the accusation of Facebook.
So that's very interesting. Okay, so finding the gold mines for me, and then I'll go take the business away from you. What an interesting segue to talking about Windows.
Yes.
So thank you very much. We didn't set that one up, but we should have. That was great. So okay, so what happened with Windows? Here's my personal take. First of all, why did it rise? Well, IBM drove the belief that there was going to be an enormous user base. This is the IBM endorsed architecture, therefore everybody's going to buy it. So all the developers got on the belief that it was going to grow, even before it grew. Because all the developers got on board, then you had the apps that caused the growth. So it's like a self-generating process. The hardware architecture lets you do pretty powerful apps for a desktop PC at the time, and it was a pretty nice architecture compared to what was available. They had open APIs, and the clone licensing drove a lot of additional growth. So what you got was Declaration of hardware, developers, clone licensing. Oh, there's going to be more hardware, more developers. Oh, there's more software available, more hardware sales. Ooh, you get more developers, boom. And they run away with the industry. What happened eventually, let me finish this one and then I'll come back to you. What happened on the decline was that Microsoft started trying to grow beyond the operating system, and they started preying on the successful software developers. So what happened was it broke the financial motivation. Even though they had this huge installed base, the feeling that developers started to get was, well, if I become successful, Microsoft is just going to take it away from me. So why should I bother? Why should I invest? So Microsoft actually drove a lot of the innovative developers out. They went to work on other things, namely the web. We'll come to that in a little bit. And then Microsoft and Intel themselves weren't able to drive all the innovation that needed to happen. So innovation on the platform really slowed down. And that's why Windows has slowed down to such a lethargic rate of change. Nobody's going to fund new desktop apps on Windows for a lot of reasons, but in part because Microsoft will kill off those things. You don't get the investment, you don't get the innovation. Now, sorry, thanks, you were patient.
Another important part of the rise was that you had to pay for it anyway if you were an OEM.
Yes.
Because of the license.
Yep.
So there's no competition.
Yep, you're right. So that's a really good point. Thanks. Okay, so the general principle here is the less business and technology friction there is facing the developers, the more applications you're going to get. So let's give a little bit of more detail on that. First of all, it needs to be easy to develop. Powerful APIs that let you do cool stuff very easily. Great documentation and support. A lot of platforms, vendors will neglect this stuff. Oh, we got great APIs. Has anyone bothered to write up the developer docs that you can actually look through and read? Sometimes, but very often not. Support. Can they ask questions? Can they get questions answered? And it cannot just be, oh, throw it open to the developers helping each other. You have to have some people assigned to helping the people who are helping the developers. If it uses existing tools and languages, that gets you a lot more developers instantly. You know, make it work with Eclipse, for instance, is a really logical thing to be doing. Easy to debug is another one that very often gets neglected. But when people are actually trying to develop apps, you know, if it's easy to develop but you can't debug the freaking thing, you're not going to be able to get the application out there. It's how do you let them get it all the way through to getting a completed product. That's what the platform's for. It's not just about APIs. It's about the full solution that lets a developer develop their product and get it done. Second, easy to sell. No artificial barriers to distribution. So in other words, you shouldn't have to go convince each carrier in the world individually to carry your application, because if you're a 5-person developer, you don't have time to go meet with 2 carriers, let alone 50 of them. Easy discovery. In other words, it has to be really easy for the users to find your application. That's one of the things that the App Store does nicely on the iPhone. Easy to market, easy to install, easy to do billing. This is very, very often neglected, and that's another one that Apple did really, really nicely. So if somebody is going to use your application, and if they have to go in order to get the application, get out their credit card, and enter it in, then it slows them down, and they worry about security and all this other stuff, and that's friction that causes you to lose customers. They just drop off at every step along the way. On the other hand, if the platform already has your billing information, like if it's on a phone and they can just add it to your phone bill, or if it's someplace else like Amazon that has an existing billing relationship and you can just click once and say you're done, that's more sales. Makes the developer more successful, makes it easier for them to make money, gets you more developers. And then reasonable financials. Reasonable means don't take more than a 20% cut in practice. Apple's taking 30, that's a little bit high. 20 works a lot better. Below 20, the developers will trade that off in order to get better marketing and other things like that. Beyond 20, it starts to hurt their financials. And then finally, either a large user base or the belief that the user base is going to get very large. That's another one iPhone's done really well. It's the sense of inevitability around that thing that drives a lot of the developers, not the actual installed base today. It's just the belief that Steve will take you someplace great. So, looking at the iPhone ecosystem and just talking about some of the strengths and weaknesses there to use it as an example. First of all, the APIs. Very capable APIs, really good. I mean, it's derived from Mac OS, so it's really nice stuff. But they put some limitations on the app functionality compared to what a lot of developers would like. It's hard to get access to some of the user data on the device. It's hard to do multitasking. You know, they've done workarounds for some pieces of it, but it still is a lot more limited than a lot of the developers would like it to be. And it prevents some of them from doing apps that they would like to do. Development environment is very familiar if you're a Mac developer, but it is not familiar if you're not a Mac developer. And you've got some people who've avoided it because of the learning curve associated with it. You got a lot of people who are focused on Java and Flash, and they would like to do more stuff for the iPhone, and they really can't do it today. That's a control thing that Steve's got around not wanting to allow other APIs on there that could then take his applications away from him. The store is built in. It's got pretty good terms. There are some issues around it, though. Apple does this weird arbitrary approval process. So you have to write the application first, send it to Apple, and then you wait for them to get back and tell you that you can sell it. And sometimes it takes a few days. Sometimes it takes a few weeks. Sometimes they forget, and you have to remind them. But you don't want to remind them too often because then you might piss them off. So you're afraid of talking to them, but if you don't talk to them, they might not do it at all. And you don't know, and it's very hard to find out your status unless you have friends at Apple. So if you're a little developer trying to start up and you're looking at that, today you may be so enthusiastic that you'll try it anyway. But that's bad because it's really asking you to risk your company. You have to develop first before you can find out if the product is actually saleable. Also, there's price pressure. What happened on the App Store was that most of the developers starting out early on thought that the best-selling apps were going to be at $9.99, and they kind of built their businesses around that. Well, it turns out they were only off by one digit, and the best-selling applications have turned out to be apps that are at 99 cents. The way the App Store works, where it ranks stuff according to popularity, the 99-cent apps get the most visibility, meaning that even if you do a great app, but it's more expensive, you don't get the same volume, so you don't get the same visibility, and so it's really hard to get in there. You get the term that some of the iPhone developers have come up with for this is what they call crapware. The crapware is in the way. It floods them out on the App Store, and they're not able to get visibility for what they call serious applications. Eventually, I think that'll be worked out, but it's going to be by using ratings and different categories of apps and other things that Apple hasn't fully done yet today. So there's more work that needs to be done. And then the user base. You know, Apple obviously has this perception that they're going to provide complete world domination. If you do a website and you keep track of mobile traffic come to your website, you see a lot of iPhones hitting the website, so people are really psyched about that. Of course, there is no guarantee that it'll continue to grow. I mean, I was there at Palm when we were doubling every single year, and we thought it was going to take over the universe, and it does until it doesn't anymore. So the bottom line on this is that actually the ultimate ecosystem, platform ecosystem, does not exist, and I'd say either on mobile or on the web. What we've got on the web is that we've got a lot of advantages around the tools. So, you know, Ajax, development, instant deployment, big user base, write once, run everywhere. You know, you're writing web apps to run on the browsers. So you got all that infrastructure is really good on the web. But on the web, the benefits you get from the integrated platform, you know, great easy discovery, billing built in, lots of support, you know, people really working the APIs. A lot of that stuff doesn't exist. On the other hand, on mobile, you have the great discovery and the stores and stuff like that, but you don't have the full open ecosystem around tools the way you do around web apps. So nobody has combined those things, the technology side and the business side, together to do what I'd consider the ultimate platform for either web development or for mobile development, which means it's a really interesting opportunity for somebody. Okay, so I talked about the history. I talked about kind of the practical, tactical stuff around what makes a platform win. The thing I want to end up with is some thoughts on where the industry is going to go next. And this is now much more speculative by me, and I want to acknowledge it is very, very dangerous to try to make a prediction or a forecast based on what you're seeing today, because inevitably the industry goes in a different direction. But nevertheless, based on what I'm seeing today, let me talk about where I think it might go. I think the big opportunity historically in this industry has come through a process of disaggregation. So you start with computers in the 40s. In the 50s, you get software that's letting computers do multiple tasks. By the 60s, you've got software as an independent business. By the 70s and 80s, you start to get the OS being separated from the hardware. And what we've had more recently is the platforms being separated from the OS. So the browser and things like that, other development tools being separated from the OS itself. So it's been a steady process of getting more and more layers in here, more and more pieces that can be worked on independently by different companies. And every time we've made one of those divisions, every time that the cells have broken apart, we've gotten a burst of innovation because you had people who could move faster in little individual pieces of the industry as opposed to being weighed down with the previous architecture. So looking for what's going to disaggregate in the future becomes really, really important. If you can see where this process is going to go, you may be able to see where some of the best business opportunities are going to come. So Sun looked at this a little while back, and they had this insight. They said the network is the computer. And the way that most people interpreted that was that they said, okay, we've got this predominant architecture in PCs where you've got an application and you've got Windows and the PC hardware, and what we're going to do is we're going to turn that into a dumb client, a light client. And so get rid of that stuff. Instead, you're going to have the application, and it'll work with, I don't know, maybe Solaris or Java, and it'll run on Spark servers on the back end. And it was like a one-for-one swap. That what we're going to do is we're going to take and replace the operating system with Sun software, and we're going to replace the hardware with Sun hardware. And other people were saying, no, it's going to be my hardware, it's going to be my software. But the idea was same old architecture, but just kind of swap it over to the web. And I personally believe that's the wrong reading of what's been going on. I think that, first of all, there's some big problems with it. Latency, the richness of the APIs that were available on the network, getting access to on-device features and data and stuff like that. As somebody who's worked in mobile now for quite a while, I can tell you the problems in mobile with that sort of light client architecture are much, much more profound. So you've got limited bandwidth on the networks, meaning that as people start to use more and more applications, you start to run out of capacity, and it happens pretty quickly, especially if you're looking at video and things like that. You've got limited overall capacity. So it's two things. It's the amount that any individual can pull through the network, the speed of the network. It's also the total capacity of the network. And that one actually turns out to be even more scarce resource. That's why when you get a conference with a bunch of iPhone users all together, they overwhelm the local cellular network. That's what's going on there. You got all sorts of coverage limits. So if you're in a pure light client architecture, I mean, you know how bad cell phone coverage is around here. How are you going to feel if your apps stop working every time you're outside of network coverage? Like, I wouldn't have any at my house, for instance. Very high latency on the networks, and it's hard to get away from that one because it's based on how the networks are built. High cost to do the data transmission back and forth. And oh, by the way, if you really are shooting a bunch of data back and forth, you run down the batteries on your mobile device really, really quickly. So the problems were already pretty problematic in here just on the desktop. You add mobile into this stuff, and it is a huge problem, and it's going to continue to be a huge problem because of the limitations of the network. So pure light client really doesn't work very well. I think the next step that we're going to see is that rather than just replacing the OS with something on the network, I think what we're doing is we're gradually in the process of busting up the operating system itself. That's the next thing that gets disaggregated. So I think the architecture of the future, rather than looking like this thing, actually ends up looking more like this. So the application is in the middle, and it can use, whenever it wants to, some things that are in the cloud and some things that are in the local software environment, and can just mix and match those things ad hoc. And that is a really, really interesting kind of way of looking at the industry. It's sort of, to some extent, it's kind of obvious. You know, if you just look at what's happening today, you'll say, well, yeah, that's what we're starting to do, and that's what I'm trying to talk about. But nobody's actually named it. You know, we talk about computing in the cloud or things like that, or computing in the network. And what I'm drawing here is not just the network. It is the whole thing, including the stuff that's on the local clients and the stuff that's on the network, and thinking of all of that stuff as one gigantic meta platform or something like that. We don't actually have a word for it. So that's one of the things I'd love to do when we've got time for discussion. What should we even call that thing? Maybe somebody's named it, but I haven't been able to find a name for it. So for now, I'm just calling it the meta platform, and I mean the meta platform because there's just one of them. It's the entirety of the clients and the network together. So last slide, and then we'll do our discussion. So what's the stuff I want you guys to remember out of this? Well, first one is, if you're a developer and you're looking at what platform should you support, I got a lot of these questions from a lot of developers. Here's the question you want to ask. Which platform is going to give me the best long-term business proposition? And that includes technology, and it includes the business infrastructure they're providing. It's not that one is more important than the other. You want both, and you should demand both if you're a developer. That's how you should be evaluating these platform vendors. Don't let them just come and say, oh, I've got a nice store, or I've got some cool tools, or something like that. Insist on seeing the entire proposition from development all the way through to selling to customers. Second, if you're a platform vendor, the real base of competition between platforms is how good is the ecosystem. If you provide a better ecosystem than the other guys, the developers will eventually get to you, assuming that you can market to them and you can reach messages to them. But eventually that's what's going to win. It's not just about having cool technology or the best logo or something like that. It's how many people can you make rich over time. That's what will really drive the developers. And then third, I think a really interesting opportunity for the future is around disaggregating the OS and figuring out how does that whole meta-platform architecture work. What belongs in the cloud? What belongs locally? How do we get a consistent software environment on all of the local clients, which is a real big problem on mobile today? How do we figure out which pieces of infrastructure need to be built and who should be building which pieces? I think Amazon with Amazon Web Services is doing some really interesting work there, but they're just one piece of it. There's lots more stuff that needs to be done. And so for my money, I think that's one of the coolest areas to look at in terms of new stuff that's happening with platforms. So with that, that's what I wanted to share today. And I don't know how much time we have for discussion, but I'm glad to do it.
20 minutes.
Excellent.
Till 5:30.
Okay, cool. Thanks. Okay. So, questions, thoughts?
There's another where word.
Uh-huh.
First use of the term vaporware.
Ooh, that's a good one. Wow, that'd go right to the beginnings of software marketing, I bet. Yeah, I don't know.
The IBM stuff.
Yeah, I mean,
Remember FUD?
mm-hmm. Yep, FUD, yep.
Yeah.
Yep, you're right. You're right. Excellent. Okay, so IBM invented it. I don't know who named it, but IBM maybe was the inventor. Interesting. Yeah, that's what happens when you let marketing people deal with technology. Yeah. Yeah, you're right. It probably came out of other. It probably predates computers, actually.
Oh yeah.
But vaporware, we should find.
The human foible.
Yeah. Yep. Cool.
You said that you called some hardware vendors failures, which, if they were pure hardware vendors and the platform sold big but died out,
Yeah.
like Commodore, I mean,
Yeah.
if their job was to sell cheap little toys, they did a hell of a job.
Yeah. Yeah.
It's dead now,
Yep. Yep.
but
You're right. You're right. It's an arbitrary thing as to deciding what's the cutoff for success or failure. What I was thinking of was, did they manage to make it go as long as they really wanted it to, and as far as they thought it was going to go? And I thought for both them and Amiga, they had kind of a burst of success, but they never managed to really get it to go where their goal was. And if you were a developer riding that wave, you would have been successful for a little while, but I'm not sure if it was long enough to make you a success long term. You know, Amiga developers, for instance, if you talked, and Amiga is a little more clear-cut than Commodore. Amiga developers, in most cases, never achieved the financial goals that they had when they set out to do it. They had to switch to Mac or something.
They intended to become a software platform for the future. They wanted to become a toy store.
That's a reasonable point. So I should reconsider the Commodore one. Good comment. Thanks. Yeah.
You mentioned this a little with the Apple App Store, but once a certain number of developers have met kind of the core needs of the user base, isn't there a self-limiting point where if you're coming with a new app, even now with the App Store, you've got 10,000 or 100,000 other apps there that one or more is free doing kind of what you're doing.
Yeah.
It just, at some point, you can't get in.
The question is there a saturation point? I think yeah, it gets more and more difficult to get in. That's the way to look at it. And always the first movers on a platform end up having the best opportunities. They don't always win, so man, I can think back about early Mac developers and how many of them ended up dominating the market long term versus doing okay for a while and then somebody else came along. But you're right, there becomes more friction. But on the other hand, what you can usually do is if you can come up with a better version of the product, something that has better features, if there are a bunch of established users, if it's an established category, then you can get a lot of buzz and you can get people over to it. So even on Palm, it was around long enough that we had multiple generations of developers. And you would have an established leader and then somebody else would come up with a better one and people would be over there really quick. Especially when the apps only cost a few bucks. There's not as much barrier to switching as there is with like Photoshop, where you spent $400 on it. And then you're not really anxious to buy another $400 illustration product. I don't care how good it is. The other big issue, though, is just getting visibility in general. When there are 20,000 apps out there, how do you get noticed? And that's where what Apple really needs to do is more work, I think around categories and especially separating apps that are entertainment apps. Like the 99-cent thing that you use, like. It's almost like using it like a ringtone. You'll use it twice and then never again just because it was kind of fun. Versus somebody who's doing a serious tool, like a business, one of my friends does business travel apps and they're trying to figure out what can they do on the iPhone. And if you do that, you need to be able to sell that for $5 or $6, $10, something like that, because you got all sorts of content licensing fees and stuff like that. Well, they really need a very clearly defined subcategory that is professional travel tools, where they're just going to duke it out with the other professional travel type people. And Apple hasn't really cut it that fine yet. I think they may get there, but they're not there yet. Yeah.
It seems to me the question is different for a platform vendor. It's how can I create the best business opportunity for me?
Okay. Yeah.
And Microsoft is in a case of, boy, they had this huge operating system business, right? But then they did something truly remarkable built on top of that, okay? These guys came in with their apps. They succeeded in bundling it. And now they've got this office business that's just as big as the operating system business built on top of it, right?
So it's an interesting question. And I was doing the question here, if you're a platform vendor, if you want to get tons of developers, what do you need to do? And that's why I focused on ecosystem. If you just want to maximize, at a time. If you want to maximize your revenue, then yeah, you eventually end up cannibalizing those guys. I would argue that that's a little bit self-defeating. I think actually what Microsoft did, especially around the web in the 1990s, was by really hammering Netscape and really hammering Java on Windows. What they did was they forced the developers further out into the cloud. They actually drove, in business terms, they drove software development out further away into the cloud, because you just couldn't do app development within the Windows platform at all. It was just too restrictive. I mean, you could do it, but it was really hard to make a big successful company. And what they did was, rather than having a situation where maybe they could have worked with it, given up a little bit of control, but kept the focus of innovation on their platform, they drove the focus of innovation completely off of the Windows platform out to a place where they have, number one, no control, number two, very little expertise and knowledge in established franchises. So I think it was very successful in defending the company's franchise for another decade. It bought them about 10 more years of revenue from Office. But the price that they're paying is today, they have created a situation where they have much less leverage, and I think it is going to be very, very difficult for them to maintain the business in the long, long term. We'll see.
Other guys have a lousy platform. JavaScript in the browser is just a terrible, terrible environment.
But if I take the rate of evolution of apps, of web apps, and I compare it to the rate of evolution of PC apps on Windows, PC apps are better, but web apps are doing this. And I will put my bet on the slope of that curve of the web app guys. Give them 5 years, and they're up here somewhere, I believe, compared to where Windows is. So we'll see. That's one of the fascinating things going on in the industry. Yeah.
Room for another revolution.
Ooh, okay.
Buying software is really bad for the consumer because it puts you at odds with the needs of the developer. The developer is motivated to not fix the bugs so they can sell you the updates. Without selling you the updates, they're dead. I saw a good product for the Mac, by the way, which was written perfectly and survived about 10 operating system releases, not needing any update. The company, of course, went out of business after about 3 years. What really works is to buy software service.
Yes.
And then you have an income stream, the interests of the developer and the consumer are pretty well aligned then. They both want no bugs.
That's an excellent one. I wish I had thought to put that in. And I think that goes to the ecosystem. Because especially if you want to do software on a rental basis, the platform vendor needs to be providing the business infrastructure to do that, so that I can feel comfortable that I've registered, that the updates are going to get flowed and installed automatically. So you need a whole set of software technologies around, let me get the updates installed, let me make sure that they're properly installed. If I want to desubscribe, I want to be sure that I can do that. There's a bunch of tricky stuff around that the platform vendor could do to make that work better. And I agree strongly. That's a really, really good point. Thanks. Yeah.
There's one company that seems to have presaged what you're doing a few years. You haven't mentioned NetApp. I mean, they're really going the same place you said.
Yeah.
And they've been heading there for a long time, and they seem to be fairly successful at it. I don't know why they're not more successful, but
cool.
They seem to have taken to heart a lot of what you've said today.
Yeah, that's a good point. I'll think about them some more. I didn't deliberately leave them out. I just hadn't thought about them that much.
How are they different from Salesforce?
NetApp, the storage people?
Oh, the storage people. I meant the, okay, right.
No, yeah, just NetApp as the cloud computing people. The one thing I didn't understand about your local hardware to the cloud is where the data lives. I mean, that's the big issue there, is you've gone totally across the endpoints there.
It's actually a really interesting question. So how do I hang on to my data if one of the vendors goes out of business? How do I make sure that it's backed up? How do you make sure this stuff is secure? You know, it's bad enough to try to do security on a PC where you can, you know, do a little wall around it. You can install your Norton or McAfee or whatever. But if I'm doing stuff that's calling on 5 different components out in the cloud, and if any one of those components is compromised, I might have security problems. To me, that's actually the essence of why there's so much business opportunity here, because all those problems need to be resolved. So I agree with you that they are issues today. I think what's happening by default is we're just kind of stumbling along and doing it because the development model is so much better for web apps. But I think the big opportunity is going to be if somebody can come up with, okay, here's how we protect the user data, here's where it should be stored, and here's how we decide when, all of those sorts of things. I think there's opportunities around doing it right.
There's also the potential that someone's going to be running their payroll for the layoff and hit the press from NetApp or from the web software.
Or worse yet, the payroll will completely get lost, and it turns out they haven't done a backup. Nokia, you know, is deploying all these mobile services, and they recently had a thing a couple of months ago where their OV stuff just crashed, and they hadn't backed it up properly, and they lost everybody's contact list. So the phone numbers, the names, all that stuff, everybody had put it in the system, and it was like, oh, we didn't realize, you know, a server overheated over the weekend, and we didn't notice it, and man, we're so embarrassed. We're sorry about that. And it's like, wow, if Nokia can do that, you know. Wow, yeah. Sorry.
We've been in this situation before. We used to put everything on the big centralized mainframe, and then all the business units discovered, hey, you know, the same was the problems you just listed, and we should have our own server and our own PCs on everybody's desk and our own data backup. And like, we've been through this, and the solution is you don't put everything in the cloud because there are fundamental elements of that.
Or you mirror it or other things like that.
Or you mirror it locally, and no cloud company is going to let you mirror their data because that's their lock-in. So, I mean, we've been here. We know the solution is you have to have your own backup, your own stuff. And we're just going to come up with the same solution, which is, you know, the cloud has some problems.
And that's why I think ultimately it's a hybrid architecture, right? Some things belong in the cloud and some don't. I do think, although I don't believe today most cloud computing companies would want to give up the data. I think but at some point in time as we go forward, competitive forces, one of them gets a little desperate and they say relative to the competitors, oh, we let you keep your data locally as well, and it becomes a competitive issue, and then it's a maturity issue in the industry. But you're right, customers will need to push.
You basically want redundancy.
Yes.
You locally, ideally you want 3 copies, remember? Because whenever you made a copy, both can get trashed. If you want, the way I put it usually, I want one at home, one in the office, one on my laptop. And some of it can go in the cloud as a 4th copy. If they go away, I'm safe. So we need 4 copies. But you have local, you have non-local.
But database management is a fairly fresh problem. That's not going to be the thing that slows this down.
It's a matter of figuring out how it plays across this and what are the standards for it and stuff. And again, that comes back to why I'm just high on the possibilities here, is just because I think that exactly this, applying what we know to this new computing environment and figuring out what do we need to do to make it work in this sort of environment, I think is a big opportunity for the industry as a whole.
One thing we haven't heard much discussion at all about is open source, or even just a concept of an open platform where one vendor doesn't dominate but control the environment. And I know that's a hard thing to conceive of, especially in the mobile space when there's all these practical issues. But do you have any thoughts on kind of success of some of the open platforms? They say Linux as the desktop Unix versus...
You know, I think, and I'll just display my biases here, right, as an Apple and Palm guy. I think open source projects are wonderful at doing some things and they're not so great at other things. I think they're wonderful at getting a bunch of people together to move quickly on technology ideas and get a bunch of stuff done. They don't do user experience very well at all. And that's one of the reasons why you see, my personal opinion, you see open source playing better at the kind of server back-end tools level, you know, places where engineers are comfortable dealing with it. And open source tends to have more trouble becoming the end user thing that end users end up dealing with, especially on mobile, where you got a really tiny screen, you've got impatient users because you take it out, use it for 10 seconds, and then put it back away. The user interface has to be really carefully crafted. And there's no accident that Apple's doing really well in smartphones. You know, why are Apple and RIM doing well? They do the best user experience work in mobile today. Why is Nokia not doing as well in smartphones? They don't do user experience very well. And you know, then you talk about the open source crowd, and you're talking about stuff like the GIMP, and what's the user experience on that? You know, and hey, they managed to make Photoshop look easy, which is really, really hard to do. And so, sorry, I'm giving you a long thought on it. So I think it's wonderful for some things. To me, one of the interesting points of balance is how do you get the really, really well-crafted user experience with the development advantages of the open source community? Because really well-crafted user experience is fascist, and open source is inherently like open, semi-chaotic, democratic. How do you bring those two things together? And I haven't seen the perfect answer to that.
The answer to that is the API. I mean, that's where the two merge.
Yep, but then that's also fascist.
Right.
That's
You've been very patient.
Another type of model I wanted to throw out there is that of something like the PlayStation, where it gets saturated, technology moves forward. Sometimes artificially, a platform like that will get re-released as a PlayStation 2 or PlayStation 3. Lots of little variants of it that creates a fresh market for all the people to start making copies of the same game in a sense. I guess you could say, is it possible that some of these other platforms will go that way too? Facebook realizes that to survive, they have to come out with Facebook 2 and reset the switch. Yeah, maybe a better example is iPhone 2. Which, resets the switch. Everyone's like, oh, I can get, the application that's the first one of this type on the iPhone 2 and make money again.
That's definitely, if you even look at Apple's history, like going from Macintosh to Macintosh 2. Macintosh 2 was enough different because it added color and expansion, a whole bunch of other things, that you got a lot of developers who simply could not do things on the Mac who were able to do stuff on the Mac too. So you got a lot of precedence, not just in the game space, you've got it in the PC space as well. So yeah, that certainly makes it possible. The interesting flip is most of the web companies like Facebook, they don't do versions, they do continuous improvement, because they're web app companies. So it's like, oh, what's this week's version? And so part of it's a marketing exercise actually, of maybe you want to aggregate some of those changes not because you have to from a technological standpoint, but because to get developers cranked, you have to combine those things together and then do a big announcement about them. It's a really interesting question. I'm not sure what the answer is, but I like where you're going with that. Yeah.
I'm still puzzled about this. You seem to say there's a contradiction between user experience and open software. Take your iPhone, just an experiment, and open it up. Not necessarily arbitrarily, but in a reasonably controlled way. You think it would lose the user experience?
It would depend on what you opened up. Well, actually, there are two.
Apple can always go back and fix the things that.
But then what you've got is you've got the fascist who can come in and clean up if the open source guys. So again, you've got.
Does it have to be a fascist to clean up? That I'm not sure.
You
take special.
Special
talents, yes, but why do they have to be fast?
You need somebody who can.
Hitler, Stalin, and these guys didn't do a good user experience as far as
Okay, so I'm using the word fascist inappropriately. You're quite right.
I agree with you, but still, what's the law?
Here's the deal. Number one, I think without having the evil genius at the start to drive it, you don't get to that point of the good experience in the first place. So to get it launched, to get the first design, I think you need that.
The fact that it was proposed at the beginning is why it's good now.
Fine, beginning, but it doesn't mean you can.
So then beyond that, you still need somebody who can break the tie.
Write for Steve's son or something. Maybe he does a better job running it open.
You need somebody who can break the tie. Because what will happen is
Firefox has to do that. Yes, some fashists in there according to you.
And so they've got some decision makers there. The trick is if you let the community decide by kind of weight of majority, kind of majority rule, you get.
It's not just democracy and everything.
The community doesn't decide. The community goes 15 different directions.
That's fine, but that important something can be
It's an interesting governance question, and I guess maybe I'm being a little too arbitrary in saying it's not possible. I haven't seen it work very well. That's what I'll say.
User experience, for
Well,
instance.
like GNOME and KDE haven't done so well on the desktop or
Yeah.
the laptop, right?
None of them have, and there are lots of business reasons for it. But it's just my general observation. Yeah, my general observation about open source projects is because the very strength of them is that you have lots of people who can do lots of different things. And they can try lots of things, and then the community kind of goes with the weighted average of which things are getting most successful, and that lets you move really fast. But a user experience to work really well usually takes a single unified vision of exactly how it's supposed to work, and that usually takes one person who's been empowered to make arbitrary decisions. Now, if you can get that open source community to say, we will empower this person to make those decisions and we'll follow them, then maybe that can work. But it takes that sort of special thing where there's an accepted leader of that open source crowd who's enabled to make those decisions.
Shouldn't that be more like an artist as opposed to a dictator?
Yeah, but you know,
Put Picasso in charge, I don't know.
some of them were kind of authoritarian too. So you know, but you're right. Yeah. So fair enough. So if you're going to do user experience with open source, you need the artist who is empowered to make arbitrary decisions. Fair enough. I think that's a reasonable thing. Yep.
Makes function according to his rules.
Yeah, the majority.
We're not going to vote.
The Democrats can shoot the bad artists. That's fine, but hopefully they recognize good artistry. They leave those alive, even if they're odd.
That's interesting. I'd love to see it tried. I'd love to see somebody in an open source project where they're trying to reach consumers, create that institution, and then get folks to follow it. That'd be.
And average is a bad metric.
Yeah, average for user experience. Average is a very bad
Even
metric.
typical is a bad metric.
Yep.
To be fair, I mean, the concept of the word platform in a developer crowd often doesn't necessarily even involve money. It involves something that I can develop code against. It'll be stable. And open source has been very successful in a number of different platforms, whether you look at the scripting languages or web infrastructure, and in fact even the iPhone. I mean, look at all the different open source stacks that are in there. So there is an aspect.
Oh, I think it's great for infrastructure. I think it's absolutely fantastic. Yeah, it's open source, no question. Open source is wonderful for plumbing. Absolutely no question whatsoever. And plumbing is critical. I'm not denigrating it at all. It's that user experience side that's trickier. But I like the discussion. I like the idea you're suggesting. I'd love to see somebody try it.
Can I get your... you can keep talking. I
Oh, okay.
Microphone.
They want the microphone. Fair enough.
Technical flows, but not the logical.
For more, please visit us at stanford.edu.